There we go. You know, it'll be clear if you have a function or not. Okay, I've seen people use little f and little g a lot. I think that's just convention. You know, people use little f and little g a lot. I've seen people do that. Okay, if you remember from the definition, little x was something from the first set. Little x was something from the first set. And we actually use little x to denote an arbitrary element from the domain. So little x is what we use to denote something from the first set, the domain. And if you go back to the definition, let me actually get back there. Little y was something in the second set, capital Y. Generally what happens is if f is our function, f is going to send x to y. But that notation could be better. So what people do, once I get there, is this. If f is your function, x goes in, what comes out is f of x. X goes into the function, f of x comes out. Right? X is a variable that represents an arbitrary element in the first set, the domain. And to represent elements in the second set, we use little y. We use little y. And generally when you do have a function from x to y, people like to write this. Namely, when x goes into the function, what comes out is f of x. Having y equal to f of x, we're saying that this f of x is in the set capital Y. We're saying that f of x is something in capital Y. And y is the variable that actually is used for f of x. You know, x goes in, f of x comes out. We have y equals f of x saying that f of x is in the set capital Y. So it's just notation. I'm trying to explain it as best I can. Since y is a variable, we call it the dependent variable, mostly because it depends on x, as you can see. And x is called an independent variable. That's just what x is called by definition. Also, this is read as f of x. It's not f times x, it's f of x. So y is a function of x. Okay. Good. Also, this happens with relations. The idea with relations and ordered pairs, my function here, what we have is that in an ordered pair, that's a function. The x coordinate is your input, and what comes out of the function is the y coordinate. X goes, so the x coordinate is your input, the y coordinate is your output. So 4 goes into the function, 7 comes out, just like in the correspondence diagrams, right? 9 is your input, 7 is the corresponding output. Another way of saying that in terms of this f notation, f of x, excuse me, is this. X comma f of x. So every ordered pair you could think of as being like this, where f is the function. In fact, we also have this. This is something else people like to write. It's really just saying the same stuff I said before. X goes into the function f. What comes out is y equals f of x. We also say y is a function of x in this case. It's just what I was saying up here. Y is a function of f of x, is what I'm saying here. Okay. I hope that makes sense. So now I figured it'd be good to let everyone try some examples as well. Basically, you're going to see what the domain and range is for each of these. Then you're going to determine, well, you're going to draw a correspondence diagram. Then you're going to determine if what you have is a relation or not. I figured to give everyone about 3 minutes to try these 3 out. It's not the hand in, but I do want everyone working. So let me just pause the recording. Okay. All right. Okay, so here, what I want to do is these three questions, right? Okay, so, I mean, even without drawing a correspondence diagram, you should be able to tell which of these are functions and which of these are not, okay? So for instance here, right? We have this relation, right? So we have 1 to 5, we have 2 through 12, we have 3 to 20, you know, we have those things, right? So here, okay, now looking at this, we can see that the domain would be the set 1, 2, and 3, right? Because those are the x coordinates. The domain is the x coordinates, 1, 2, and 3. The range would be 5, 12, and 20. You know, those are the y coordinates. Also, okay, also we have arrows, right, going from 1 to 5, from 2 to 12, from 3 to 20. You know, I said you had to draw the correspondence diagram. And right away, you should be able to see that, oh, this is a function. How do we know that? Each input, each domain element only has one output. Each domain element has only one element in the range. Like so, okay? So that's what happens here. So each domain only has one element in the range. Okay, good, good. So this is a function. Okay, for this one, the domain would be 5, as you can see. It would be 10 and 15, right? That's the domain. Again, you don't list an element, excuse me, you don't list an element more than once. So we have 5, 10, 15. And what about the range? We have 9, we have 10, we have 7, and we have 100. These are all in the range. And you can see from here that we're not going to have a function, right? And why is that? Mostly because 5, 9, and 5, 10 are here. 5, 9, and 5, 10 are both in here. Right? Because what does this tell us? This tells us 5 is assigned to 9 and 5 is also assigned to 10, right? That's what's happening here. 5 goes to 9, 5 goes to 10. Right? So in other words, you have an input with two outputs, an input with two outputs. So we don't have a function here. It's a relation, but we don't have a function. What about this one? Well, here we have the domain would be 2, 12, 4, and 7. 2, 12, 4, and 7. For the range, we would have 8, 100, 2, 8 is already listed. And again, what do? Well, we just draw the arrow. So 2 to 8, 2, arrow 8. 12 to 100, 12, arrow 100. 4 to 2, we have 4, arrow 2. And finally, 7, arrow 8. But again, this is a function, right? And why is this a function? Because from each domain element, you only have one arrow coming out of it. Each domain element, you only have one arrow coming out. Okay, that's what we have. That's what has to happen when you have a function. You know, 2 only has output 8. 7 also has output 8, but that's okay. 12 has output 100. 4 has output 2. You know, one thing in the machine, for each input, you get one output in the machine when you think of it as a function. Now, are there any questions about that? Okay, let me just see something, because I don't know if I'll be able to, but let me see if we can start the next thing. Okay, I mean, this is what I'm going to start next time. Let me just quickly I don't know if I have time really, I have 20 seconds, but next time what we're gonna do is we're gonna connect this to graphing. Okay. That's what we're gonna do. We're gonna see if it comes up quickly. We're gonna connect it to graphs and the vertical line test. Basically what's gonna happen is from any relation, you can make a graph. And the other way around. And we'll see that some graphs give us functions, some don't. We'll see that next time. So if I don't hear from you, I'll see you on Wednesday. So